Welcome to this HP Expert One presentation. In this video, we're going to discuss IP subnetting. IP subnetting is one of those subjects that a lot of new network engineers struggle with. Hopefully, in this video, I'll be able to simplify subnetting for you and help you answer any questions with regards to subnetting quickly and easily. The subnetting that we're discussing here is IP version 4 subnetting and not IP version 6 subnetting. This topic has been broken into two separate videos. In the first video, I'm going to show you two methods to quickly and easily answer questions such as, what subnet is this host on? Or, what is the last host on the subnet? What is the first host on this subnet? I'm going to show you two methods. Firstly, the binary method, and secondly, the quick method to answer those questions. I suggest that you look at both and then decide which method works best for you. In the second video, I'm going to show you how to create multiple subnets when given a specific network or subnet. So you'll be able to answer questions such as, subnet this network into at least 10 subnets, or subnet this network into subnets each having 10 hosts per subnet. So if you're comfortable with questions such as first host on subnet, last host on subnet, then jump straight to the second video where we'll discuss the subnetting of a network into a certain number of subnets or subnets that support a certain number of hosts. So in this first video, we're going to work out the following. When given an IP address, we'll be able to work out the subnet address, the first host in that subnet, the last host in that subnet, and the broadcast address. So in other words, if given an IP address of 10.111/24, we'll be able to work out those four options. We're going to look at two methods, the binary method and the quick method. I suggest you choose one or the other and then get good at that specific method. There are many ways to do subnetting, many tricks, many options. I personally think the best thing to do is to select a method that works for you and then use that method. I think binary is very important to understand, but as the quick method name implies, it's very quick and easy to answer subnetting questions using the quick method. So here's an example. We have a PC with IP address 192.168.10.18/24. What IP address would router 1 be configured with if it is to use the first IP address in the same subnet as the PC? What's the broadcast address used by this PC? What IP address would the router be configured with if it is to use the last IP address in the same subnet as the PC? And lastly, what subnet is the PC part of? So this is the first, this is the last, this is the broadcast, and this is the subnet address. Once you get good at these methods, you should be able to work that out in about 30 to 60 seconds. So without further ado, let me show you how to do that. Firstly, by using the binary method, and once I've shown you a few examples, I'll show you the quick method. When using the binary method, you need to remember 4 rules. To work out the network or subnet address, you fill the host portion of an address with binary zeros. To work out the broadcast address, you fill the host portion of an address with binary 1s. To work out the first host, you fill the host portion of an address with binary 0s except for the last bit, which is set to binary 1. And lastly, to work out the last host, fill the host portion of an address with binary 1s except for the last bit, which you set to binary 0. If you remember those 4 rules, you'll be able to work out the answer to any of the previous questions very quickly. Let's start with a basic example. We've been given an IP address of 192.168.118/24, which can also be written as 192.168.118.255.255.255.0. Now, as you learned in the IP addressing video, these two are equivalent. 255 equates to 8 binary 1s, so 8 plus 8 plus 8 gives you 24. /24 or 255.255.255 implies that the first 3 octets are network, the last octet is host. Please refer to the IP addressing video if you're not sure about /24s and host and network portion. But once again, the first 3 octets are network, the last octet is host. So in this example, the network portion is written in black and the host portion is written in red. There's no point converting the network portion to binary. So for subnet, first host, last host, and broadcast, I've just left it in dotted decimal notation. But for the host portion, we need to remember our rules. So the first rule is to work out the subnet address, fill the host portion with binary zeros. So 8 binary zeros, when converted to decimal, gives you 0. So the subnet address for this host is 192.168.1.0. To work out the first host, fill the host portion of the address with binary zeros except for the last bit, which is set to binary 1. Converting that back to decimal will give us 1. So the first host is 192.168.1.1. For the last host, fill the host portion of the address with binary 1s except for the last 0. If you convert that back to decimal, you'll get 254. And to work out the broadcast address, fill the host portion with binary 1s, which will give you 255. And there you have it. For this address, 192.168.1.18, the subnet is 192.168.1.0, first host 192.168.1.1, last host 192.168.1.254, and the broadcast 192.168.1.255. To speed things up, you may want to work out the broadcast address and just subtract 1 from it. That'll give you the last host. Or work out the subnet address and just add 1, and that'll give you the first host. The rules to remember is to work out the subnet, fill the host portion with zeros. To work out the broadcast address, fill it with binary 1s. To work out the first host, fill with binary zeros except for the last bit, which is set to binary 1. And to work out the last host, fill with binary 1s except for the last bit, which is set to binary 0. And that'll give us these answers as we've just worked out. So if you were asked to configure a router with the first IP address in the same subnet as this PC with IP address 192.168.1.18/24, the router would be configured with IP address 192.168.1.1/24 or 255.255.255.0 in dotted decimal notation. Here's another example which is more complicated. In this example, the PC has been configured with an IP address of 192.168.35.123/20, which can also be written as 255.255.240.0. This is more complicated because the mask does not fall on the octet boundary. In other words, it's not a /8 or /16 or a /24. The network and host portion lies somewhere in the third octet. So network host splits somewhere in here. So in this example, /20 means that there are 20 bits of the 32-bit IP address which are network or subnet, and the remaining 12 bits are used for the host portion. So here's our IP address, 172.16.35.123/20 mask. There's a split between network or subnet and host in the third octet. So somewhere in that octet, we need to work out how many bits are network, how many bits are host. So the first octet is 8 bits. The second octet is also 8 bits. That gives us a total of 16 bits. The third octet is 8 bits in size, but 4 bits of that equals network. 20 minus 16 gives us 4. So 4 bits of that octet are network and 4 bits are host. Just to reiterate, that's 8 bits, 16 bits, full octet would be 24 bits, but the split is in the middle of that third octet. So somewhere in here we've got a network or subnet and host split. That therefore means that we need to convert the third octet and fourth octet into binary because they both have host bits. There's no need to convert the first two octets to binary because no host bits are found in the first two octets. So 172.16 stays the same. 35 in binary is 2 binary zeros, binary 1, 3 binary zeros, 2 binary 1s, and 123 is this in binary. So all I've done is convert the decimal to binary, but only for 35 and 123 because they both contain host bits. There's therefore a split between network subnet and host. This is the network portion / subnet portion, and this is the host portion of the address. That can be worked out because we were given a /20 mask. 8 bits plus 8 bits is 16, 17, 18, 19, 20. So this is 20 bits. In other words, the network or subnet portion has 20 bits. Host portion is the remaining bits. We can draw a line at this point to indicate the split between network and host. So to work out the answers, you need to remember our 4 rules. The first rule states that to work out the network or subnet address, you need to fill the host portion of an address with binary zeros. So once again, here's our address, 172.16.35.123. We've got a line at this point indicating that this portion is the network portion. This is the host portion. So 20 bits are network, the remaining bits are host portion. So to work out the subnet, we need to fill the host portion with binary zeros. That means we have 172 in the first octet, 16 in the second octet. In the third octet, the first 4 bits are 0010 and the remaining 4 bits are quadruple 0 in binary. So looking at this octet, we've got 0010 followed by 4 zeros, and if you convert that to decimal, you're going to get 32. The last octet is populated with zeros, so that's equal to 0. So the answer is the subnet is 172.16.32.0. The host portion of the address has been populated with zeros, and working it out, this is the answer. The second rule states that to work out the first host address, we need to fill the host portion of the address with binary zeros except for the last bit, which we set to binary 1. So here's our address, 172.16.35.123. The first 20 bits of the address are network. So this portion once again is network. This portion is host. So to work out the first host, we fill the host portion with binary zeros except for the last bit, which is set to 1. So once again, the answer is 172.16. We never converted that portion to binary. The third octet, taken as a full octet, is 0010 quadruple 0, which equals 32. The last octet equals 1. So the answer is 172.16.32.1. The host portion is filled with binary zeros except for the last bit, which is a binary 1. To work out the last host, we need to fill the host portion of the address with binary 1s except for the last bit, which is set to binary 0. So our address 172.16.35.123, network portion 20 bits. We fill the host portion of the address with binary 1s except for the last bit, which is a binary 0. So 172 equals 172, 16 equals 16. The third octet is 0010 followed by 4 binary 1s. That equates to 47. The last octet is filled with binary 1s except for the last bit, which is a binary 0, and that equates to 254. So the answer is 172, 16, 47, 254. That is the last host on the same subnet as 172.16.35.123. To work out the broadcast address, we fill the host portion of the address with binary ones. So our network 172.16.35.123 has 20 bits of network or subnet. So the host portion needs to be filled with binary ones. The first octet is 172. Second octet is 16. The third octet equals 0010 followed by 4 binary ones, which equals 47. The last octet is populated fully with binary ones. That equals 255. So the broadcast address for this host with a /20 mask is 172.16.47.255. Notice the host portion is populated with binary ones. So to summarize, subnet is 172.16.32.0, first host .1, last host 254, broadcast address 255. Remember the rules. To work out the subnet, fill the host portion with zeros. Broadcast, fill the host portion with ones. First host, fill with zeros apart from the last bit, which is a 1. Last host, fill with binary ones. Last bit is a binary 0. We have successfully worked out first host, last host, subnet, and broadcast for this IP address with this mask. Here's one more example using the binary method, and then after this I'm going to show you the quick method. If a PC had an IP address of 172.16.129.1/17, what is the subnet, broadcast, first host, and last host? Here once again we need to work out where the subnet and host portions are split. So which portion is subnet and which portion is host? So /17 means that 17 bits of the 32-bit IP address are used for network and subnet, and the remaining 15 bits are used for the host portion. So the first octet is 8 bits, second octet is 8 bits. 8 plus 8 is 16. So 17 puts the split in the third octet. So once again, the split between subnet and host is in the third octet. First octet once again is 8 bits, second octet 8 bits. The split is somewhere here. So we convert the third and fourth octet into binary because they both contain host bits. So the last octet in binary is 7 binary zeros followed by a binary 1. 129. 1 binary 1 followed by 6 binary zeros followed by a binary 1. 172.16 are not converted to binary because there are no host bits in those octets. So we can draw a line once again at this point. The reason why /17 is the subnet mask that we were given. 8 bits, 8 bits, 1 bit gives us 17. 17 bits are part of the network or subnet. The remaining bits are host. So, to work out the network and subnet address, we fill the host portion of the address with binary zeros. /17 mask. So we've drawn our line at this point. The host portion is filled with binary zeros. So first octet is 172. Second octet is 16. The third octet in binary looks like this, which equals 128. Last octet equals 0. So the subnet address for 172.16.129.1 is 172.16.128.0. To work out the first host, we fill the host portion of the address with binary zeros, except for the last bit, which is a binary 1. So the host portion filled with binary zeros, except for the last bit, which is a binary 1. That gives us 172.16, third octet, which is 128. Last octet, which is 1. So the first host on the subnet where this host resides is 172.16.128.1 host portion filled with zeros except for the last bit, which is a 1. To work out the last host, we fill the host portion with binary 1s except for the last bit, which is a binary 0. So 172.16, 1. Host portion is filled with binary 1s except for the last bit, which is a binary 0. So 172.16. Third octet is filled with 1s. That means 255. The last octet is filled with 1s except for the last bit, which is 254. So the last host on the same subnet as 172.16.129.1 is 172.16.255.254. Notice host portion is filled with 1s except for the last bit, which is a 0. The last step is to work out the broadcast address. To work out the broadcast, we fill the host portion with binary 1s. So 172.16.1 host portion is filled with binary 1s. So 172 is 172, 16, 16. Third octet is 8 binary 1s, which means 255. Last octet is the same, 8 binary 1s, which means 255. So the broadcast address for 172.16.129.1 is 172.16.255.255. For this host, subnet address, first host address, last host address, and broadcast address, we've answered the questions. I hope that those 3 examples have helped you learn the binary method to work out the subnet, first host, last host, and broadcast address when presented with an IP address of a host and its subnet mask. Now that you've seen the binary method, let's look at the quick method, which allows you very quickly to work out answers to questions, such as subnet, broadcast, first host, and last host. Now the quick method is reliant on you remembering tables and methods rather than relying on binary. The first table to remember is the following. And for ease of use, only remember the top values. So we've got values 128, 64, 32, 16, 8, 4, 2, and 1. The first line just shows you the decimal values for the binary numbers in an octet. So 1 followed by 7 zeros is 128. 3 binary zeros followed by 1 followed by 4 binary zeros is 16. I would be comfortable remembering this table before trying to work out subnets. In the IP addressing video, I explained these values in a lot of detail, so I'm not going to cover it again here. The second line is simply 256 minus the first line. So 256 minus 128 gives you 128. 256 minus 64 gives you 192. 256 minus 32 gives you 224, and so forth and so on. Lastly, 256 minus 1 gives you 255. So for ease of use, remember the top line, and then simply subtract that number from 256 to get the second number. So in this example, we've got address 172.16.35.123/20, or the decimal equivalent would be 255.255.240.0. What is the first host, last host, subnet, and broadcast address for this host address? So to work this out, firstly, you need to find out where the subnet mask is not 255. So where is the split between subnet and host? And then secondly, take a note that the subnet and host portion changes in that octet. In other words, if it's not equal to 255, it will once again contain network, subnet, and host bits, so just remember which octet that is. So here's our address, 172.16.35.123. Subnet is 255.255.240.0. So this is network, this is network. Notice 255.255. But here there's a change because it's not 255. So the octet is split between subnet and host in the third octet. The last octet is host portion. But here there's a change. So the third octet has both network and host. So what is the mask in that octet? 240. So we're going to remember 240. The next step is to take our table and subtract 240 from 256. So 256 minus 240 is 16. We could use our table to work that out very quickly. In the table in step 1, we worked out that 256 minus 16 is 240. So in other words, 256 minus 240 is 16. So we can very quickly see that the value is 16. What the 16 means here is that the networks are incrementing in values of 16. So the first network in the third octet is going to be 0, then 16, then 32, then 48, and so forth and so on. 16 is the increment of the network. So once again, just to reiterate, the third octet had a value of 240. 240 is not 255. That means there's a split between subnet and host in the third octet. 256 minus 240 equals 16. Our table would allow us to work that out very quickly. The network is incrementing in values of 0, 16, 32, 48. Notice the address is 35. So the next step is to work out where 35 is in the range of networks worked out in step 2. So we worked out that the networks are in multiples of 16. So the first network is 0. Second one is 16. Third one is 32. Fourth one is 48. That means 35 is between 32 and 48. To do this, you just start at 0 and then go on until you are past the value in question. So in other words, we started at 0 and we went to 48, bypassing 35. We know that 35 is between 32 and 48. So the subnet for 172.16.35.123 is 172.16.32.0. To work that out, you leave the network portion of the address the same. In other words, the blue portion of this address is left the same. Remember, these had 255 in the subnet mask, so they remain the same. The subnet host octet lies between 32 and 48, as per our previous calculation. We then round down 35 to 32. Now we worked out that we're going in multiples of 16. 35 is between 32 and 48, so we round down to 32. So once again, network portion remains the same, 172.16. The subnet host octet, which has network and host bits, lies between 32 and 48, so we round down, in this case to 32. Host portion set to 0. 172.16.35.123 is on this subnet, 172.16.32.0. So, in summary, we know that our host is on subnet 172.16.32.0. That's what we've just worked out. We also know that the next subnet is 172.16.48.0. Remember, we're going in multiples in this example of 16. So our host is on this subnet. The next subnet is 48. Now, to help you with the next step, here's an analogy from the real world. When driving, you've probably seen an odometer many times in the past. It will roll over from 1 to 2 to 3, all the way up to 9, and then it'll roll over from 9 to 0, and the 0 to the left will then move to 1. So just think about what happens in your car as you're driving. So with the standard odometer, let's say there's a value of 7 zeros followed by a 1. So it's a brand new vehicle. It's got 1 mile on it. If you drive another mile, it will roll over to 7 zeros followed by 2. If you drive a little bit further, and it's now 7 zeros followed by a 9, and you drive 1 additional mile, it will roll over to 6 zeros followed by 1 zero. By the same token, if you've driven 999 miles and you drive 1 additional mile, it'll roll over and look as the follows. Now you would never do this on a vehicle, but if you took 1,000 miles and you subtracted 1 mile, it would roll back to the following. So here we've got 4 zeros, a 1 followed by 3 zeros, and if you remove 1, it changes to 5 zeros followed by 3 nines. So that's in the physical world on a vehicle. Now using that analogy with binary, think of a binary odometer. Here you've got an IP address 10.11254. Plus 1 will give you 10.11255. However, 10.11255 plus 1 will roll that over to 10.1.2.0. Remember, in an octet, the maximum value is 255. So if you add 1 there, it can't go to 256 in an IP address. It has to roll over the next octet. So 10.1.1.255 plus 1 gives you 10.1.2.0. Plus 1 would give you 10.1.2.1. Or if you reverse that process, 10.1.2.0 minus 1 would give you 10.1.1.255. Think of how an odometer works in a vehicle and use that analogy for the binary odometer. To work out the broadcast address for our host, take the next network that we worked out less 1. So we worked out that our network is 172.16.32.0. We worked out that the next network is 172.16.48.0. So 172.16.48.0 less 1 gives you 172.16.47.255. So255. address for our host, 172.16.35.123, is 172.16.47.255. To work that out, keep the network portion the same. The host subnet portion is equal to 1 less than the next network. Roll back the binary as if you're rolling back an odometer. So we've rolled back 48.0 minus 1 gives you 172.16.47.255. That's the broadcast address. Now using the answers we've worked out, we worked out that our subnet was 172.16.32.0. To work out the first host, take the subnet plus 1. So 172.16.32.0 plus 1 gives you 172.16.32.1. The last host is equal to the broadcast less 1. Broadcast is 172.16.47.255. Less 1 gives you 172.16.47.254. And that's it. We've worked out the subnet, which is 172.16.32.0. The first host address is 172.16.32.1. The broadcast is 172.16.47.255. And the last host is 172.16.47.254 for the host 172.16.35.123 with the subnet mask 255.255.240.0. So that's how you work out the information using the quick method. It's really up to you which method you decide to use. Decide to use the binary method or the quick method or use another method. There are many ways to work out the same information when doing subnetting. Find out what works for yourself and stick with that method. That concludes this first video showing you how to work out subnet, first host, last host, and broadcast address when presented with an IP address and subnet mask. I showed you 2 methods to work out those values. In the next video, I'm going to continue the discussion showing you how to work out number of subnets or number of hosts. For more information, please go to hp.com/go/expert1.